A man hikes 10 miles through hills, rivers, and dense forest. After hours of walking, he checks his GPS. It says, "You are 1 mile away from your starting point." No error, no malfunction. Just one concept that changes how we measure movement forever. That situation isn't rare. It happens every time something moves and returns near where it began. It's not about how far you've gone, it's about where you started and where you end. With that one thing, the entire idea of motion changes. What is displacement? Displacement is the change in position from the starting point to the ending point. It doesn't care about how twisty, long, or complex the path was. It only looks at one thing: the shortest straight line connection between start and end. Walk 5 steps forward, then walk 5 steps backward. The total distance is 10 steps. But your displacement? Displacement is a vector. That means direction matters. If you end up to the left of your start, that's negative. If you end up to the right, that's positive. Without this direction, the numbers lose meaning. With that concept, every move tells a clearer story. A car travels 60 kilometers east, then 40 kilometers west. What is the displacement? With these values, it might seem like a trick question, but all that matters is where the car ends up compared to where it started. Pause here if you'd like to solve it yourself. The net movement is 60 kilometers right minus 40 kilometers left. The car is 20 kilometers east of where it started. So the displacement is plus 20 kilometers. A drone flies 40 meters north, 30 meters east, then 40 meters south. What is the displacement? With these moves, the final position might not be obvious, but using coordinates or a simple sketch reveals the truth. Try solving before the solution. Solution: 40 meters north, then 40 meters south cancels out. The drone ends up directly east of its starting point, 30 meters away. So the displacement is 30 meters east. That's the power of direction-aware motion. GPS uses displacement to calculate how far from home. Engineers use it to measure how structures move under pressure. Animators use it to track character positions frame by frame. And in physics, it's the starting point for velocity, acceleration, and beyond. With this idea, any motion becomes measurable and meaningful. Displacement measures where something ends up, not how far it traveled. It includes direction, making it smarter than just distance. With this one concept, motion starts making sense in every field. Watch your world differently now. It's not just about movement. It's about change in position.